Hello and welcome to my short presentation about developing a JSON-LD-based LRMI metadata profile. Thanks to the organizers of DCMI Virtual and to Phil for moderating the session. My name is Adrian. I call myself a web librarian these days. For more than 10 years, I've been working with metadata on the web and especially with linked open data. I work at the HBZ in Cologne, Germany. Our open infrastructure team focuses on providing Lobit, Lobit.org, and we also have a lot to do with OER metadata and infrastructure, for example in the ScoHub project and the ERSI OER search index project. I initiated an OER metadata group where we come together to prevent parallel work with regard to OER metadata and to define recommendations. Let's recap what a metadata profile actually does before diving into a specific profile. It's a definition of how existing vocabularies or metadata schemas are reused in an application or in a community by indicating which properties and types from these existing metadata schemas are used and what constraints for their usage are there, like mandatory fields, cardinality, value constraints, etc. Tom Baker and Karen Coyle at SWIP19 have nicely illustrated in what different ways a profile can reuse existing profiles. It might be a subset of a main vocabulary, or it could use a main vocabulary and other vocabularies and add those two, or it might take subsets of different vocabularies to define this profile. What can a profile look like? There are many different ways. One is a human-only readable document like a PDF, or you can define machine-readable schemas for specific formats, for example, an XML schema or JSON schema. You could use something like Shex or Shackle to define graph shapes for RDF data. And in the future, you might use the Dublin Core application profile core vocabulary, which will let you define an application profile using a metadata profile using tabular data. And there are probably lots of other ways to define and publish your metadata profile. So let's now move on to concrete profile, an LRMI profile for higher education OER. So there might be too many acronyms. OER means Open Educational Resources, which are free, accessible and openly licensed resources for teaching and learning. And LRMI, I think Phil already cleared that up in the introduction, so I don't have to go there. Why are we working on an LRMI profile? There's more than one motive for developing this profile. Here are three of them. There's, for one, great interest in LRMI in the German-speaking OER community, but there haven't been any easy instructions for implementation. And and I already mentioned OERC, the OER search index, which we are working on, and there we are in need of a standards-oriented JSON schema for learning resources metadata as an index schema for which we can normalize all the data into. And there already exists a LOM-based XML profile for describing OER. It was also developed within Kim, but we want to we are working with HTTP and JSON and web APIs, and we think this approach is more future proof, and this is what we actually need now. Before taking a brief look at the profile itself, I want to present the process of developing it. The profile is being developed as a JSON schema first, and which defines the fields, the value types, and which controlled vocabularies are used. And the controlled vocabularies are published separately as SCOS files and are referenced in the schema. And this schema then can be tried out in the SCOAP editor. I will show you soon. And so you can try it. You can try it out how it works and look up the vocabularies and all this. So, as we focus on the JSON schema first, we will not have a human readable documentation of the metadata profile until the end of the process. However, the profile is exemplified and can be tried out in the SCOAP editor, as I already said. So let's take a look at how this actually works. Let's take a look at the JSON schema and the SCOAP editor. This is the editor. You can type in some data here, and then you will see the JSON coming out from what you typed in here, and can copy it and use it or do other things with it. And yes, so how do I configure this editor? How does a JSON schema work? For example, this part of the schema defines the property name, which will appear as title in the editor, and which expects an unconstrained string. And this is what it looks like in the editor then. And this one adds the field image to the JSON data, which will be shown as image in the editor, and which expects a string of format URI. And as you can see, I can also define a placeholder for the web form here in the schema, which is quite nice. This will look like this. Then I have this empty field with a placeholder. If I put in an image, everything is okay. If I put in something, if I put in a URL to an image, everything is okay. If I put in something that is not a URL, there will be an error message. So as you can see, the JSON schema is not only used for building the web form, but also for validating the input. You can also enumerate possible values for a field, like we do here for the type field, using types from schema.org, and these were then shown in a drop down suggested in the web form. This is how it looks like when I reference the SCOS vocabulary by using the by adding the SCOHub lookup widget here, and by saying which in which scheme the reference SCOS concept should reside. This is what it looks like in the editor then. Yeah, you can look up the concepts from the SCOS scheme and then choose them to be added to the about field, the subject field. What I really like about this setup are the automatic tests. The schema is tested against two sets of files, valid JSON files and invalid JSON files. And whenever we notice a file that is invalid, but the schema doesn't catch this, we add the file to the invalid folder, update the schema so that the tests pass, and then the schema will be stricter and better, and we are moving on. And also, these example files are helpful for people who are implementing the profile. They can take a look at them as examples. Okay, going back to the controlled values. Where exactly do these values come from? I already talked about SCOS and SCOAP. I mentioned them before. So let's take a brief look about at how this works exactly. These controlled vocabularies must be published with SCOHub vocabs, which is one SCOHub module, and this works like this. You publish a turtle RDF file on GitHub or GitLab. Both are supported, and maintain them there, can edit there. And whenever you set up a webhook in your settings, and whenever you change something in your SCOS concept scheme, the vocabulary will be built, will be newly built on SCOHub, having a nice HTML UI for humans to read, but there's also JSON-LD as RDF serialization under the hood. And yeah, there's a blog post linked here if you want to know the details and how to try it out yourself. This is what it looks like. Here's this subject classification in German we are using in the SCOHub editor. It's published on GitHub as turtle file, and this is what it looks like in SCOHub when it's published via the webhook. Okay, I've talked about the process now, but you probably want to know something from the schema, the LRMI data. Here are a few examples. I will focus on the thing that might not be the normal stuff, but it might be of interest to others. One thing, as you can see, we in JSON-LD you add this context for declaring namespaces. Basically, as you can see here, we're using schema.org vocab as the base vocab, but we're also adding some SCOS vocabulary, some SCOS properties we are using. So basically, this is kind of example we had before, a metadata profile which uses a subset of schema.org plus a subset of SCOS. We recently implemented some kind of localization. For one thing, we found it important to add the language of the metadata. The metadata is written in, so the language OER is described in to the metadata, and this can be done by adding a default language in the context. When I say add language DE, each field, each literal string in the data will be tagged with DE, with German. But we also have the possibility for the values from the controlled vocabulary to add different languages. So if we have our SCOS vocabulary with English, German, or with multilingual labels, we can also add them to the JSON data. Here, for example, we have this concept N222 from the Hochschulfächersystematik, and you could add the prefLabel in German and in English. Another thing we added in the context of the OER search index was this main entity of page property array from schema.org. It comes to add some metadata. So basically, in this object we are talking about where the metadata itself comes from. We say we have this provider, it's a OER repository we got it from, and we get some information on when the data was created there. And we could even add additional metadata from different sources if we get the same OER described in different sources, and we deduplicate this. We can add the metadata for all those resources to this array. which is quite useful. Yeah, so that was it. My brief look into what we are working on, and thanks for watching. And if you want to take a look at the details or want to use some SCOAP components or whatever, here are some links you could follow.